So no, we haven't started yet. We're going to just give it, I think, 2 or 3 more minutes. Usually people tend to arrive this time. I know definitely myself, before joining the meeting, I had a bunch of technical difficulties, which was extremely frustrating. Teams just never work. Essentially, my teams managed to try and join the call twice at the same time. So only one succeeded, and the other one kept on making this, disconnect ringing noise in my ear. And I think I would have been gone crazy to try and deliver training like that. So very happy that got sorted out. And yeah, thank you. I've been doing well. It's definitely been a while. I'm very excited to be back. And once again, my surprise appearance here is mainly for just, delivering the training and all of that. All of the administrative type questions, Jono would be the one for that. So I've got 1 more minute left, and then we can properly kick off. Um, Perfect, everyone. I'm going to give us a slow start. We are going to basically do a deep dive into SQL injection. Majority of today is going to be more practical demonstration. I think that's kind of how I prefer it. And hopefully everything will make sense, but I'm going to show like a lot of things quite a few times so that it sticks, and I'm also going to show you kind of the way how I learned SQL injection and how I could, better my conceptual understanding of it as well. So with that said, let's jump into it. So last week we discussed CSRF, covering one of the last attacks for client-side attacks, which we'll cover again quickly just now in terms of the concept between client-side and server-side, of course. And then today we are going to be focusing on SQL injection as an introductory to our server-side injection attacks. And then next week, we're going to be looking at file upload, which is essentially an extension, I would say, of the server-side injection attacks. But there's a lot more nuance there, especially because file upload is quite a beast to tackle. So as I said, let's start off with injection attacks. So far, you have covered some concepts between that sits within the client side of things. Now, when I'm talking about client side, this is everything you see within your browser. So if you were to navigate to a web app, everything that you visually see in Google Chrome or Firefox, that is what I refer to as being the client side. Now, some of the client side attacks that we have covered so far is like the cross-site scripting attack. Now, if we want to think of it conceptually, this is whenever the payload itself is attacking either the browser or the payload is executing within the browser itself. Now, a good way to kind of think about it is the payload is executing on the host's computer because naturally their browser is actually running on their computer. It's using the machine's resources, meaning their memory, CPU, etc. And typically the payload is actually accessible to the end user. For example, if you were to inject a cross-site scripting payload, meaning you are actually injecting client-side code into a victim's browser, that piece of code is normally actually accessible to the victim. Now, let's contrast that with server-side attacks, where now instead of the payload actually executing on the client side or the browser, the payload is now going to be executing on the actual server hosting the application. So once again, you can think of it as the payload is executing on the server using the server's resources. So it's actually using the server's memory, CPU, processing power, and all of that. Now, in this case, the actual code or attack vector is typically hidden from the end user, meaning the person sitting in front of the browser. They won't actually see the payload because everything is executing server side. Now, with injection attacks as a whole, to think of it from more of a conceptual level, especially this doesn't really is just applicable to server-side attacks, but of course, with that in mind, it's whenever you have some type of code that accepts user input, meaning anything that comes from the end user's browser, and it uses that code directly, or the user input directly within the backend code. So in this case, we have two examples. One, you are actually creating a string variable, and with this variable, or what we're going to call command, you are actually concatenating or appending the user input directly into that string. Now, if you don't actually check what type of string or user input you've accepted here, naturally an attacker would be able to inject something malicious, causing some unintended behavior. Now, for the focus of today, we are going to look at SQL injection as an example for our injection attacks. Now, but before we get into SQL injection, I'd first touch on what is SQL and what is it actually used for? Because usually when you try and understand a certain type of attack, you'd first want to understand what type of technology you are actually attacking. That's the best way to understand and actually properly formulate your attacks from that point onwards. So with SQL, it's essentially a structured query language, essentially the acronym there, and it's used to specifically store data on the server side, and this data can then be queried by the actual application itself. So I'm going to show you a quick example, kind of what that might look like, just to, solidify that concept over here. So in this case, what we are looking at, maybe I can just zoom in a little bit. I'll maybe switch my camera off there. There you go, it's a little bit bigger and maybe even an extra zoom for us as well. There we go, I think that hopefully is enough. So if we're looking at SQL, you would have your application running in the backend, and then let's think of an application where you can view products that you want to buy, for example. In this case, let's actually see what happens here. I see we have a product table, which we'll get to now. So let's say you have an application where you can view the products that you want to buy and actually go and buy them. Where are all of this information actually stored? Right? So you have to think with all of the data that's presented to you as an end user, that data has to come from somewhere. Now, it's not always a SQL database. It can be stored on disk, your actual hard disk. It can be stored as files, but most likely you're going to find that it's going to be stored in a SQL database. So actually, I was hoping, let me see if I can do this. Okay. So with our explanation of literally saying, please select, and star is almost like a wildcard. So we're going to say select all from the products table. So select all columns from the products table. Let's see what happens if we run this, if it actually passes through. Let's go. So now we can see after that query has been executed, we can see that all of our products actually have been retrieved from our database. Now, if you can imagine, once again, if you had an application that viewed all of this product information for you to buy, let's say maybe like your Checkers 6060 or something like that. Now, all of this information will then actually be formatted and displayed properly on the actual GUI and for your end user to actually interact with it, right? But essentially, every time you would click on, like, if you imagine the web application, you click on the products tab or view all products, you would then be, the application in the backend would actually go and execute a query, maybe something similar to this, and then it would go and extract all of the information from the database. Now, let's say you are clicking on a specific product on the web app, because let's say we want to actually buy some Chang. Now, I have absolutely no idea what that is, so hopefully it's not something too weird. So then the query would look something a little bit more like this, where if you were to click on that product, it might submit the product name. So here, select all columns from the products table, where product name equals Chang. So now if you were to run that query, we should see that only this product information were retrieved. Now, normally it doesn't really work on product names because product names aren't always that unique. It might work with the actual product ID. Now, before I change to the product ID, notice that this is actually a string data type. It's denoted with your single quotes. It can also be double quotes over here, but you can even see with a different color over here. Oh, okay, this looks like we can't actually use double quotes. I think in some backend languages it actually allows you to do that. But in this case, we should have the Chang product over here. Now let's actually change this to product ID. Now, if I were to submit a 2 over here, we might see that the product is returned again. And then, of course, we can change this to something else. Let's say you were clicking elsewhere. Now, if you have the web application in front of you and you're clicking on the different products, it might be passing through the actual product identifier. And that is how it essentially extracts your information. So I just wanted to give the concept in terms of how your actual application is communicating with the SQL database. It's doing it in the form of a SQL statement where it can then perform some logic in terms of what it wants to actually extract. Another example I have over here is if we were to potentially select all of the columns within the customers table. So here we can see select all columns from the customers table. Let's say we only want the customer name. So select customer name. Okay, copy through. Let's see. Okay, the copy paste is definitely broken. Customer name from customers. And you'll see it only extracts all of your customer names at this point, because of course we are only asked for the customer name column. And you can also be more specific, as we showed earlier. So let's say we want to select all of the customers where they live in the city, maybe let's call it Berlin. Now we can see only one person of the customers is actually associated with the Berlin city. Let's do maybe, Germany as a country. Now I can see everyone that's associated with the country column over here. So hopefully this kind of shows how you can communicate with your SQL database in different ways. And when we are attacking SQL database as a server-side injection attack, we need to always remember how this technology works. So if we are going to inject into, for example, a SQL query, we need to understand, okay, how is this actually accepting my user input to go and extract a specific type of data? The good one was a little bit earlier when we looked at the products table. So I'm just going to bring that back for us. So let's say we've got the products table over here, and let's say we are looking at the product specifically number 2. There we go. So now you can imagine the web application, when you click on it, it is going to send your user input in, and in this case, it would be in the form of a product ID parameter potentially. And then it's going to send that within the HTTP request that you would be able to see with Burp Suite, of course. And then that is going to be processed within the SQL query over here. Now, my question to you is, well, if I understand that this is my user input, in this case, user input, is being accepted by a SQL query, doesn't that mean I can potentially do some harm to this? So if my user input is directly accepted, consider the following payload. Let's say I want to actually retrieve all of the actual data entries within the products table. I don't want to just see product number 2. I would want to potentially give it a logical statement here that's always going to be true. Because if we try and think about how this query works, it's going to say, select all of the columns from the products table where the product ID is equal to 2. So what happens is the backend or the SQL database is going to go through each row until it finds where the product ID is equal to 2. Then when that condition is met, it's going to say the condition is met, I need to retrieve all of the columns. But what if I want to retrieve all of the rows here? Okay, so what we would want to do is give it a condition that when it goes down row by row, that it's always true. So maybe we can do something like 1 equals 1, right? So all 1 equals 1 is always going to be true. But importantly, our user input is accepted within these 2 single quotes. So how do we actually get this all 1 equals 1 to work within this product ID without breaking the syntax? For example, if I were to just simply inject all 1 equals 1 there, I run the query and I believe nothing is going to happen here, right? Because simply there is no product ID that is called 2 or 1 equals 1. Okay, so let's take our payload back out again. So since we have the 2 single quotes over here, maybe, of course, we can then also inject our own single quote space, and then let's see what happens now. So we're going to inject that single quote, 4 equals 1, 1 equals 1. But now we have this kind of trailing piece of code over here. Now that we can simply comment out with a commenting character specific to the database. Let's see what happens if we run this now. Now, instead of that, the query is going to return just the product number 2. It's going to return each row within the products table because I've specified, please, I've actually injected a statement that's always true for each of the row, and it's going to extract all of the information here. Now, and just as a quick one here, just to quickly show some, more of how SQL works, if we put an AND, now this is just simply, please bring the products where product equals 2 and 1 equals 1. So this is always true. It doesn't really affect the actual query here. However, if we were to change 1 equals 0, now we have an add statement where this might be true. This is definitely always going to be false. So this query in essence is always going to be false as well. Meaning if I run this query, nothing should be returned. Now, the reason why this concept is important is because this allows you to manipulate the behavior of the actual SQL database. And if you have the ability to manipulate that behavior. That's going to allow you to actually further inject into your application and hopefully perform some SQL injection. So we are going to come back to this example over here. I'm going to continue with some slides, but essentially when we are talking about SQL, this is what you would want to have in your head. Okay, let's move back to SQL slides. Let's go. Okay, so now with SQL injection, we're going to go through some of the steps here as to how you would normally actually inject it. The first one being you would want to identify a specific application that you know is using SQL. I mean, that's step one, right? You can't try and attack an application with SQL injection if it's not even using SQL. That simply doesn't make sense. So first, try and figure out, is it actually using SQL or a database in the backend? Then we need to find a specific endpoint that we can actually try and inject to. So this is whenever you are seeing, maybe some identifiers in your request, something that's usually unique, or, maybe some search functionality, something like that. So then, after your input is going to be accepted into whatever query you've identified, what's going to happen is your malicious input is then validated, and your custom query that you've injected is actually going to communicate with the database, because as we shown a little bit earlier with the W3 Schools example, you've now basically obtained the ability to manipulate the SQL query and change its intended behavior. And that's going to allow an attacker to gain access to all of the information in the database. Essentially, everything that the application was allowed to read from the database, that is exactly the type of things that the attacker would now be able to do, because the attacker is injecting into code that the application is using at the end of the day. Now, with this type of access, the attacker would be able to view, read, alter information, add information to the database, essentially do what they want there. So let's go quickly through a basic example here. One of the goals for SQL injection is to extract information, and this is very similar to what I just showed you, where if you have an endpoint, maybe a specific user's endpoint, and now imagine this endpoint that we see over here, which says SQLi/users, and then we have the U parameter equals OSI Monet. So then what's happening here, if the functionality that's presented to you is maybe, when you click on your profile within your application and you want to see your profile details, then you have this specific endpoint. And let's say you have authentication and authorization actually in place, where if you were to access OS Monet, maybe this is your username and it actually allows it to go through. But if you were to enter a different type of username, it actually blocks you. So then what can we do? If we look at this piece of code in the bottom here, this is an example of where maybe we have some type of SQL query that directly takes the user input from the HTTP request. And it's, in this case, the end query is going to be select all columns from the users table where the username is equal to OSI Monet. Now, how do we get all of the usernames from the database? Let's manipulate the database logic here, or the query logic, so that we can actually do that. In this case, what we're going to do is we are simply going to inject a single quote to actually escape out of the original query syntax. Then we're going to inject our own SQL logic, which is going to be or 1 equals 1. And then you'll see here, we don't actually close off the single quote. And now, just to kind of show that again for you, if we have something here where you have the, what's its name? The single quotes, you don't always actually have to comment anything out, but that is, of course, an option. So in this case, the payload would be single quotes over there, and then or 1 equals 1, there we go, and then 1 equals, there we go. So the bits that I'm highlighting, that was our payload over here. Single quote or single quote 1, single quote equals single quote 1, because we are utilizing the end bits over there. And if we run this query, we should be able to see all of the actual data being returned. So hopefully you'll see by actually working with a SQL query that works, and you can visually see how it works, you're understanding the technology you're attacking. This is kind of how you can flourish in terms of understanding what you're attacking and also how SQL injection works as a whole. So that's definitely going to be quite important for you. This is exactly how I kind of learned SQL injection. I kept on playing around with W3 Schools tutorial because this allows you to work with the query as intended, and then we start doing something malicious. So every time I find an application that might be vulnerable to SQL injection, I first try and build the query structure here, kind of how I hypothesize it to be, and then I go and inject into it, trying to do something malicious. Let's see if I can move this back again. So then over here, based off this information, how can we try and access the admin account? So it's a good question here. And I mean, you can think about it a little bit, but the main concept is in your user database. Naturally, within your user database, there should be something that dictates who is your admin accounts or who are your admin accounts. And the idea would be you would need to actually extract all of the columns within your users table, and then potentially your users table will have maybe a flag that says is admin, and then maybe that is set to true or false. Maybe it has a role identifier in it, and then you have to actually go look at a different table. So like there is all of the information you need to actually get that answer is stored within the SQL database itself. So now we've spoken about a SQL injection attack where we want to extract information, but remember, that's not all there is to SQL injection. You can't kind of limit yourself into thinking with SQL injection or this type of attack, I can only do this one thing. So a good example of that is if you were to think back to cross-site scripting and someone asks you, what can you do with cross-site scripting? Maybe your very first answer is you could steal someone's cookies. Sure, but that's definitely just the tip of the iceberg. There's so much more you can do with it. Same thing goes for SQL injection. Now, in this case, we're going to be looking at how to bypass authentication, actually. And if you were to think of a login page, so you've got your username and password, you can, so if you were to think of that flow of how the login authentication portion works, it's going to take a username, it takes your password, and then it has to verify with the authenticator, is this actually a valid user? It'll most likely do that through SQL. And here's an example SQL query where it does that, where this is quite a basic one. But in this case, it takes the username, admin, it takes the password, admin. So imagine you are now trying to log into the application using default credentials, admin, admin. And then what's going to happen is it goes through each row of the users table and it looks for the username that's admin and the password that's admin as well. It's going to go through each row or record, as we can call it, and it's going to return 0 records or 0 rows, meaning it is false. And therefore, if no records are returned, you have an access denied. But what if we give it a statement that's always true? So now we have the username admin. In this case, what we are going to assume is that the username admin actually exists. Then we have the password field, in which case we are going to inject single quote or single quote 1, single quote equals single quote 1. And then, of course, that kind of completes the syntax there. So what's going to happen here is it's going to go through each row of the users table until it finds a username that is equal to admin. And then it's going to see, okay, is your password blank, because in this case, single quote, that is essentially blank, or 1 equals 1, which is always true. So that means whenever the row is found with the username equals to admin, it's actually going to return that row's records and all of its columns. And that's going to then tell the application, yes, I have actually found this user. This is now an authenticated user. So in that case, you are actually able to bypass authentication on a login page by manipulating the SQL query that is used for authentication. Now, let's look at another way to actually, or not another way, just kind of a deeper dive into how we can extract information from the database. And in this case, we're actually looking at, okay, if we want to extract information from a database, how can we do this? But we want to extract information not from the current table that is in use. We want to extract information from any table that we can find. How can we actually do that? So the most common way is to look at using the union select statement. Now, conceptually, what this does is it allows you to almost add another query to your existing query. So in this case, the example that we have here, it is select all of the columns from the products table where the code equals BK101. Now, that is a query in itself, right? And that has executed, as we can see here, with the very first row, the SAS survival book was returned. So that query has executed. Now, we add another query on top of it that we want the database to execute. We say, okay, you've executed this one. Now do a union select all columns from the users table. Now it's actually going to retrieve all of the columns from the users table and give that to you as an additional result as well. So let's actually quickly show that over here, because I think it's going to be union select was quite hard for me at least to conceptualize in the beginning. So what I would want to do here is okay, so we have the product ID. Yes, okay, let's extract, let's actually just fix this query for us. Let's select all columns with the product ID equals 1. Okay, but let's say we want to now also go and extract all of the customer tables or customer columns, right? So what we'd want to do is do a union select all columns from, well, let's do the customers table. Okay, so now if we were to do that, there might potentially become an error. And the big reason for this is when you are using your union select statement, you need to make sure that the two tables that you are using, the products table and the customers table, that they actually have the same amount of columns. So if we were to look at the customer, the products table, we can see we've got 1, 2, 3, 4, 5, 6 columns, right? And if we look at the customers table, it's going to have 7 columns. So now what we want to do is we want to make sure that we are actually combining the two queries so that when we are doing it, both have the same amount of columns. So let's say we've got our, okay, from products, let's do a union select. From an attacker's perspective, what you would want to do, and we'll get to that in the slides a little bit, is we saw now the customers table's got 1, 2, 3, 4, 5, 6, 7 columns, and then the products table have got 6 columns. How do you know how many columns they are from an attacker's perspective? It's quite hard to figure that out, right? So what you'd want to do is actually use an ordered by statement. Now, this is going to allow you to figure out how many columns there are. So as we've already seen, there are 6 columns, but let's see what happens when I say order by 5. Order by 5, simply it does execute, there's no errors. The reason is because when you are asking the database, please select all of the columns from the products table and order it by the 5th column. This essentially means that the database is going to see, do I have at least 5 columns? Yes, in fact, I do. So I'm not going to, it's not going to result in any type of error. Let's do an order by 6. And you'll see it also goes through. This 100% makes sense. But if we do try to specify it an order by 7, for example, you will see that there is an error. Now, this is going to tell us, you can literally see here, the order by position number is out of range of the number of items in the selected list because we only have 6 columns. We don't have 7 columns. Now, in this case, we definitely know that the products table has 6 columns. Same thing for the customers table. However, of course, in this case, it has 6 columns, but it has, in fact, 1 more. There we go, so we can see it's still executed. And if we were to say order by 8, it actually doesn't work. So the concept that I'm trying to teach you here is essentially when you are using your union select statement, you need to make sure that the amount of columns you are specifying is actually equivalent to each other. So if you want to see that in action, let's do a union select. Now, simply what this does is I am going to tell the database, don't select anything. So we've got 1, 2, 3, 4, 5, 6, 7, I believe. And if we were to ask it to do that, it is actually going to extract all the information. But let's just clean this data up a little bit. So I'm going to say, let's just retrieve 1 customer ID for us. So we've got a customer ID number 1. Now you can see number of records is 2, but that's strange because we can only see 1 record over here. The reason is I literally told the database, do a union select, but don't fetch any information. Select nothing, essentially. So that record is still retrieved and produced to the user, but nothing is actually populated within it. And also just to kind of prove that if we were to mismatch the amount of columns that we're specifying here, it is going to result in an error. And also maybe 1 too little is also going to result in an error. So we need to make sure that when we are performing the union select attack, that we do have the correct number of columns specified over here. So now at this point, we are actually almost ready to properly use our union select statement. However, the last thing we would need to do is we want to make sure that for these columns that we're extracting, this actually needs to match the data types that's extracted from the first table over here. So customer ID, this could either be an integer or a string. This is definitely a string. Postal code, this could most likely be a string because you do get postal codes that starts with 00, for example. So it seems like all of these are most likely strings. And what we would need to do then is if we were to just see if our union select statement is working, we are going to run something like this. Now what this does is it says union select nothing, select ASD, so I'm actually giving it the data that it needs to select, so it's not going to actually pull anything from the database. Nothing, 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 nothing. And we can see the second row here, the data I gave it is actually now populated there, right? So it's following all of our instructions. So the next step that if you were to imagine yourself being an attacker is, okay, how do I actually know which tables to go and attack, right? Well, there's something called the information schema, and we'll get to it in a bit. I'm going to go back to the slides, but when we get there, we are going to extract the actual table names and column names. Because remember, you need to imagine that if you are at this point, you are injecting your union select statement, how do I know what tables they are and what tables I want to extract information from? Okay, so try and keep that in mind. So looking back at the slides over here, we have our union select ready. And in this case, you'll notice that we didn't have any nulls. And the reason for that is coincidentally in their scenario, the products table and the users table have the same amount of columns. Here is in the case where you don't know the amount of columns, as I just showed you in a practical level, you can actually use the order by statement to determine how many columns they are. And you'll see here, as we showed earlier, when you hit an error, you know for a fact, okay, there is definitely 3 columns and not 4. So as I mentioned, we now are at the point where we actually need to extract the table names and column names from what we would want to attack. Because hopefully, as you've seen, when we've worked with the SQL statement so far, we are always specifying the table that we are going to extract information from. And we're not always specifying the column names, but sometimes you actually want to be a little bit more specific and specify the column names you are attacking, especially if there is a lot of information that you are extracting from this database. But now the question comes in, if you're at the point where you can inject SQL statements, how do I actually get this information from the tables? So in order to get the table names and column names, you can actually query the information schema table. Now, this is actually a table within your database that holds all of the table names and then all of the column names. And just in Oracle, we have a little bit of a different syntax here. Now, literally, it would look something like this. We have a screenshot where on the left-hand side, we can see if we were to perform a select star from information schema.tables, this is essentially what we would get. So it's going to produce all of the actual table names and display it to the user. And from that point, you can actually see, okay, now we have all of the table names, but I don't know what potential column names they might be. So then you would want to extract all of the information from the actual column schema. So let's do that as well. So I'm going to quickly jump back to my practical here. And we can see when we are selecting all of the columns from the information schema.tables, it does actually produce all of the table names that is available to us. So now we have customers, employees, order details, and all of these things. Now, maybe employees is actually a very interesting table because if you're an employee, you would most likely have a username or maybe login details, or there might be some sensitive information there. So what column names are available for us over there? So we can simply do select all. Let's do select all of the column names. Just want to get the correct syntax. So it's underscore column name from information schema columns. So this is going to get all of the column names, hopefully. There we go. But we actually want to get a specific table, which was, I believe it was employees. Let's hope I spelled that right. I definitely didn't. Okay. Third, let's go one back where we just look at the tables again so that I can do a proper copy paste. So we have employees over here. And then we are going to, let's see here, select all of the columns from the information schema.columns where table underscore name, and then you give it the table name, right? So let's jump back to practical. So select all from, go, information schema columns. Then you're going to copy this across for us. So and now we can see all of the columns, and let's just quickly run through this again. select the column name from the information schema.columns, where the table name equals employees over here. I see the error earlier wasn't a spelling mistake, it was rather I didn't put this in a string. So now we can actually see for the employee columns, we have employee ID, last name, first name, birth, and all of these things. So now if we want to actually extract all of this information over here, maybe we can do something like select employee ID. Okay. Or maybe do first name from go. Now we've actually extracted all of the first names from the employees table. So, I mean, we're going to go through a bunch of these examples, and we are also going to look at an actual vulnerable application performing the exact same steps that I'm performing here. But hopefully this still drives into the fact that when you are looking at SQL, you simply need to use SQL for what it is and actually manipulate it so that you can extract all the information you need to kind of dig deeper into the type of information that you would want to extract. So with SQL injection, there are also other types of SQL injection, and we're not going to specifically dive into this a lot, but with these other types of SQL injection, in this case, we've got second order SQL injection. Now, with second order SQL injection, you can imagine it being where you inject your user input, but your SQL payload isn't executed immediately. Instead, your user input is saved somewhere, and then in a different function, it's actually being called and then used at a later stage, where then it's executed. That's why it's called second order SQL injection. Some people actually call it stored SQL injection sometimes, but second order is a little bit more accurate, where you have a second thing that's happening before your SQL payload is executed. A good example here is the last one. Maybe your payload is actually embedded into an uploaded file. So you upload a file, and then maybe there is some code afterwards that inspects all of your file, and then based on the contents of the file, potentially then extracts information from the database, or maybe verifies some things in the database. This will be a vector for second order SQL injection. Then also we have something called an inference attack with SQL injection. Sometimes you don't get your direct output that you're looking for. So this could fall under your blind SQL injection, right? Where you are now performing your SQL injection attack, but you can't actually see the results that's happening. But you have the ability to manipulate how the database is actually behaving. So what you'd want to do is you perform an inference attack, and it's directly to the word where you are inferring certain results based on the behavior you are inducing. So what I'm trying to say here is, let's say there's a piece of functionality, you do you put in a statement that's always true, you see the application performs in a certain way, then you inject a statement that's always false, and now suddenly the application is behaving in a different way. This could give you an indication that you can infer there is a SQL injection vulnerability. And now you can use this type of behavior to actually infer some results out of the actual database. For example, let's say you are building a query, and this is something hopefully we'll be able to look at a little bit later. You're building a query where you are checking the very first character within a specific column is equal to a U. If this is not the case, perform a delay. So then what you do is you kind of make a comparison. Okay, is the first entry of this column, does the first character start with a U? If not, 10-second delay. If it or if it is actually U, 10-second delay maybe, and then if it's not, no delay. You know, something like that. The idea is you want to be change the behavior of the actual database. But we will look at an actual practical example like this. most of the SQL injection that we find is in-band injection. Well, I would say most of it that you would identify. It is sometimes very hard to identify blind SQL injection because you don't always like it's not always as intuitive that the applications suddenly behave differently. However, sometimes the response is sent in a different channel. Yes, that's 100% true. So maybe you buy something and then in your purchasing cart, let's say you have selected a specific order, and then this order is then processed in the backend. But those parameters that accepted the actual order is vulnerable to SQL injection, and that actually emails some information back to your email account. Now, that could be where you have a little bit of an out-of-band SQL injection, where you are injecting at one location, but the result is coming to you through a whole different band of communication, like email, SMS, or something like that. This is a lot harder to identify, but Burp Suite has some functionality. But if you don't want to use Burp Suite, you can also have listeners ready, where whenever you are trying to perform some type of out-of-band attack, you want to make sure that you are sending the resulting data to your out-of-band listener. So this hopefully will be a little bit more clear when we go through the practical. But some key points here is when you are looking at an application, first understand the actual functionality. Are there any type of input that feeds into a potential SQL query, or do you think this interacts with the database? Try to inject into it. Very good example for me is 100% if you see some type of e-commerce platform and there is maybe some products that you want to buy. Now, the thought process is, where is the application getting this information from? Where's this data from? Once again, it can literally be stored as PDF files or, just text files. That's possible, but most likely it's going to be stored in a database, which then gives you the indication, okay, I can see there's some parameters here. I'm going to start injecting into it. Your very first step in terms of identifying SQL injection would be to first confirm the SQL injection's behavior. So don't go and throw in all of your SQL injection payloads from the get-go. Just start off with some ands and ors, and specifically an and as well, where we'd want to just make sure, am I actually understanding the functionality appropriately? And the reason why I say this is sometimes the functionality you are attacking can be quite sensitive. Something happened to me on an actual practical assessment with a client where there was a type of functionality where you can change your password. Now, I started injecting some single quotes there, and I started seeing the applications behaving strangely. Now, if I were to think that is injectable, as in it's vulnerable to SQL injection, if I were to straight up inject an OR 1 = 1, meaning it's going to go through potentially all of the users, that could mean I would change the passwords for all of the users within the database. Now, since this test was in production, that would be quite awful and very impactful, because now you are changing all of your clients' customers' passwords. You simply don't want to do that. So what you'd want to do is start off small, start off with something safe, do an AND statement, confirm the behavior, and then take it from there. So before we go into the defense, I think it would be nice to jump into the actual demonstration quickly, and then we can go back to it. So what I would want to do here is just make sure that my practical is still running. Seems like it is, which is always good news for me. I'm going to share it on the correct screen just now. There we go. So here you can see we have our vulnerable banking application. And of course, this is going to be our segue into a very nice demonstration for SQL injection. Firstly, what I would want to take you through is where do we find SQL injection, right? So we have our functionalities here. We have accounts, we've got payments, and we've got cards. Let's go into the middle one, and we've got all of our payment information over here. Just check something. There we go. So now if we were to look at the request over here, I've got my, am I intercepting? I'm not. Just going to run that endpoint again. And now we'll see in our, okay, I have a feeling I need to turn off my camera for this one so that the screen is a little bit bigger. There we go. So if we are looking at the request and response for the payments endpoint. So let's quickly look at the application again. When we clicked on payments over here, what happened? So we can see that when clicking on the payments button, all of the records of my transactions actually got displayed here on the application. So now my thinking is, where did this come from, right? It has to be stored somewhere. So if I'm looking at the request, we can see, yes, it's a GET request. That is expected because we are retrieving information. We can see I am authenticated. This is good. But how does it know what information it's actually getting or whose information it's getting? Of course, it's going to use my JSession ID, my authentication material. Now, that's how it actually retrieves all of the information over here. And kind of, we don't have really at this point any injectable point, except maybe the JSON ID. Now, I don't think this will work because usually they don't use your JSession ID directly in the SQL query. They would instead take your JSession ID, identify who you are and retrieve your username, and then take the query from there. So if I were to inject a SQL, a SQL payload here as in a single quote, I can see it returns me back to the login page, which is expected because it's not using the JSession ID directly. Okay, so this is not SQL injectable in my opinion, at least so far. Okay, now let's click on one of the endpoints over here. Immediately that I saw is we can see a parameter popping up. So looking at that request over here, we've got payments details equals ID. So now things are a little bit more interesting because it's not directly using my JSession ID anymore. It is using the ID parameter. Why? Because when I clicked on a specific transaction ID, I wanted to view the transaction details for the specified one that I clicked on. The query looks like this. Select all columns from the payments table where let's maybe do, I don't know, payment ID equals 12. So let's say we are thinking this is what our query looks like in the backend. So if I were to inject it to this place and I'd said, okay, or 1 equals 1, then what it's going to happen is hopefully all of the records are going to be returned. Let's actually go and try that. So I'm going to do it over here. And let's say or 1 equals 1. But before I do that, remember that I said that we would rather want to use a safe type of statement, right? And yes, I do know with this type of querying functionality, if I were to inject an or 1 equals 1, it's not going to perform any harm, but it's good to have good habits, right? So let's change this into a 1 equals 1 and an AND statement. So that if we say, please go and retrieve where the transaction ID equals 12 and true. So it's going to retrieve the data. Yes, of course it is. Now, this isn't actually enough information for us to now determine SQL injection is there. Because what if they are just simply, cutting the rest of this off? They are only looking at the 12 over here. So we want to elicit some type of behavior. So what we're going to do is we're going to say and 1 equals 0. So that's something that's always false. Now the expected behavior, if it is actually vulnerable, that no records should be returned. And here we can see no records were returned. So this is already a very good indication that it is vulnerable to SQL injection. Now what I'm going to do is I'm going to change this AND statement to an OR, 1 equals 1. And we are going to fire it off. And we can see all of the transaction IDs starting at 1 all the way through has now suddenly been returned. Now, this is quite a high risk vulnerability here because now we can suddenly see everyone's transaction details, right? And this is not something we want. But at this point, we have basically confirmed SQL injection. However, this isn't actually enough, right? We want to fully exploit this. We want to extract all of the information from all of the tables within the database. So how do we do that? Remember, the first step here is we can identify this as a certain type of SQL injection. In this case, it's called, usually they refer to it classic in-band SQL injection. In-band meaning it's not going through a separate communication channel. We can see between our communication between our browser and the actual backend application. We can there see the behavior of the SQL injection. And we can actually see the data being returned directly to us. Okay, so now that we have identified the type of SQL injection we have, let's go further and actually exploit it so that we can get information from other tables. First thing we want to do is we want to go for a union select query, but we don't know how many columns there are. Okay, so let's first figure that out. Let's do an order by, well, I'm going to make a guess here. We've got 1, 2, 3, 4, 5, 6, 7, 8. Surely there is at least 8 columns. Yes, we had data returned, so that definitely worked out. Now, let's just confirm. Are there potentially more, but we can't really see it? Yes, there are actually more columns being returned. Okay, so, or actually used by the table. So now let's try 10, order by 10. Okay, it's still working. Let's do an order by 11. Okay, now we see an error happen because we're not actually retrieving any data anymore. And we are 100% certain that there are 10 columns in use with the table that's currently being queried. Now let's set up our union select statement. So we've got, let's do capital letters, union select. And let's start off with just making sure our structure is ready. So we're going to do 10 nulls to match the amount of columns we've just identified. So it's 1, 2, 4, 5, 6, 7, 8, 9, 10. And let's do a semicolon there for fun. Now we can see our record with 0 data there because I told it to not retrieve anything has been populated over here. Now, let's go and identify some of the data types and also let's identify where I actually want the data to be returned within this view that we have here. What I mean by that is we have the column numbers over here and each of it would represent where it's going to be populated, right? So let's do this one over here. I'm going to just inject a capital A, or maybe let's do MWR. Okay, this looks like an error. Now, the error happened here because we are having a mismatch with the data type. We actually injected a string. It did not like that. Does it like a 1? It does like a 1, meaning this data type is actually an integer. So that's a good example of where we had to actually identify the correct data type. So I am quickly just going to try a random one. Let's do number 4. So sometimes what I do with my methodology is sequentially going through things sometimes take a little bit long. So I would kind of do a spotlight search where sometimes, you hoy it there and then you see what happens, and sometimes it's a little bit faster. And if that doesn't work, 100% go through a sequential search. Here we can see we've got MWR and it's actually being displayed under your sort code. So yes, it is a string and it's displayed over here. Now let's call that B for now. Let's do one left to it, the account number. Let's fire it off. And now we can see A and B. Okay, this is perfect. Now we are basically set up to start extracting table names and column names. So the first thing we'd want to do is similar to what the slide showed us earlier. We are now going to query our information schema.tables. So let's do that. We are going to ask, please select all of the table names. So we are querying the table name column, and we are querying it from the information underscore schema.tables table. After firing that off, let me quickly just go through it again. We asked for the table name from the information schema.tables, and we are keeping the rest as is. So this actually extracted all of the table names that we would want to look for. And now we can see a bunch of interesting things, right? We have accounts, we have users, transactions, mobile state, and a bunch of other ones over here. And now we can actually go and be like, okay, as the attacker, what is our goal? What would we actually like to achieve over here? So we have the accounts, cards, mobile state, periodic transactions, and users. So if I had the attacker goal to maybe compromise all of the actual users within Bazaar Bank, so all of the actual customers, I am going to be looking at compromising the users table, right? That's kind of the one we'll be looking at. So let's attack the user table. To do that, I would need to first understand what are all the column names provided by the users table. So I'm going to run through this query now. We are going to query the union select the column name from the information schema.columns, where the table name is, or the column name is, or the table name is users. Sorry, yes, where table, there's the table name. Table name equals users. So after firing off that query over here, union select all of the column names from the information schema.columns, where the table name equals users, we can now actually see all of the column names within the users table. Now we have email addresses. This is very useful for maybe password changes, maybe if we want to do some phishing. Obviously, we have the password column. This is naturally very useful for us. We have the username as well. We have user ID. Security token potentially is very useful for us. Security passphrase. So maybe the security passphrase is used when you have forgotten your username and you have to default to your security passphrase. So like there is a bunch of very useful information here. But the ones that I'm looking for is we've got the column name for the username and then the password one as well. So what I would want to do here, maybe restructure this query where we are going to look for the username column, going to look for the password column, and we are going to look at it or extract it from the users table. After firing that off, we have selected username, password from the users table. And notice again, by using our union select over here, the very first query is still executing, but then it's combining the results of our secondary query. And it extracted all of the usernames and passwords over here. Now, at this point, if the passwords have been stored in clear text, we are in a position where we have fully compromised all of the user accounts. However, if they did what they were supposed to, all of the passwords over here would be hashed in a certain way. So then you would then extract all of the passwords and you would need to crack all of those hashes. We are going to be covering cryptography a little bit later in the internship, I believe, but essentially you have to store your passwords in a secure format so that it's not just kind of accessible and available to everyone. So at this point, we have compromised all of Bazaar Bank's customers, and that is extremely, extremely useful. So I see we're on 7.12 over here. I would quickly like to show an example of blind SQL injection on Bazaar Bank as well. So if we were to look at the accounts functionality, similar thing here. Look at the functionality. It has pulled all of my accounts. Now I'm clicking on a specific account and I see the ID over here. Now, if I were to inject something, let's say do and 1 = 1. Okay, still works. This is very good news. And 1 = 0. It seems like I'm getting kind of like an error message saying it couldn't find that account. Okay, so now what I would want to do is we are going to do, something similar over here. I believe I do have it ready for us. You would first need to know all of the column names and all of that, but I'd like to show you what it would look like if you had a scenario where you are fully blind and you don't actually see the results of the query when you are attempting to perform your SQL injection. I would like to just demonstrate what that might look like. First one, what I would do is I would need to extract all of the table names. And what you can do with that is I have this query over here, and I'm going to walk us through it. So what we're doing over here is, since we can't actually extract information directly from the HTTP response or the behavior here, we are going to do some inference. So we are going to first identify, okay, let's pull the very first table name in the information schema, a kind of table over here. So I think that should actually be like that table name from, there we go. So what's going to happen here is we are going to essentially select the very first table name, and we're going to see, okay, is it actually longer than 1 or not? I believe I messed up the query. Let's quickly replace it. There we go. So what we're seeing here is we are evaluating, okay, is the very first row, is the length of the result that's coming back at least longer than 1? Yes, it is. So what that means is the very first table that we are getting back is actually the length of that table name is longer than the character 1. So is it longer than 2? Yes, it is. Let's maybe skip a little bit. Is it longer than 5? It is. If we were to see some type of error, that's when we know we need to stop. So let's do 7. Let's do 8. There we go. So we are getting an error message over here, and that simply means that the condition over here has failed, because the length of the table name that we have extracted is not larger than 8. So that means it should be equals to 8, right? 100%. So now the condition is true again, and we actually see from the behavior that we have successfully identified the first table name is actually a length of 8 characters. Now what I would do is I would perform something similar to this. We are going to go through it character by character. And since we have 8 characters we need to go through, we are going to select a substring of the result that comes back. So for the table name that comes back over here, let's look at the very first character. So if we're looking at the substring function, what that does is it says, okay, let's start from a position number 1 of your word, and then how many characters would you like to extract? Well, only one, because we're looking at the very first character, right? So let's say we want to see if the table name starts with the letter A. Yes, it does. And if we were to submit something else, like a B, it's going to be an error. So based on the results that I'm getting here, I can infer that the table name starts with the letter A. Now, for the next letter, we would need to actually increase this integer over here, because now we want to grab the first letter and the second letter. What is it going to be? Is it going to be AA? So no, it's not AA. Is it AB potentially? It's not AB. Is it AC? Yes, it is AC. Okay, so then what you would do is you would go through this recursively until you actually find the correct table name. And what I've done here is just showing you the end result, which is if we do an AND substring, we grab all 8 characters and we can see the actual result is accounts. So the table name for this table is actually called accounts. Now, this is the method that would happen if you want to extract all of the information from a blind perspective. Perfect. So we had the 2 examples over here, one fully exploiting to compromise all of the Bazaar customers, and the one a little bit of an introduction as to what blind SQL injection with an inference attack might look like. So if you want to explore this further, I would 100% recommend looking at Portswigger. It's going to take you through each step very well, and you should be able to be 100% fine, as long along with, of course, our assignment, and that's going to kind of teach you all the tricks and stuff that you would need to get through it. So let's jump back to the slides. I'm going to quickly put the camera back on. And now, since we've explored SQL injection and also a little bit of a concept of server-side injection attacks, let's touch on how to actually remediate it. With SQL injection, the primary defense is actually to utilize parameterized queries, also known as bind parameters. And the concept here is you don't want user input to be directly used in any type of backend code. So what parameterized queries does for us, it gives us a conceptual split between what is user input and what is SQL query. So the first point here is kind of what it might look like in actual code. So you see there, instead of inject or using user input, we are using something as similar to a placeholder. So we have here something that says @code, or maybe @user input or @product code. That's a placeholder for where user input has to be used after the SQL query is actually constructed. Let's kind of look at a piece of vulnerable code over here. So if we look at line number 5, we can see we are currently building this SQL query in the backend using user input directly. So we can see this is the SQL query we're using, and it says select all columns from site users where the username equals, and then we have our user input, which is directly extracted from the login username over here. So we are using the user input directly in our SQL query when we are building it. Same with the password portion. Then after that, the SQL query is used directly in the SQL command, and that is then actually executed, which is what makes us vulnerable to SQL injection. If we look at the remediation, we can see once again at line number 5 that we now, instead of passing the user input directly, we have placeholders. Now the SQL query is constructed as a string variable, and then with the placeholders, the SQL query is actually converted into a SQL command, which is then sent to the database over here at line number 8. So you have your connection string where it connects to, sends that command, and your SQL query is essentially compiled. Then after that, after your SQL query has been constructed, then only then you actually add your user input over here into the placeholders that you want. So there's no way that the user input is actually tampering with the actual query that we constructed. Now, if we take this back just conceptually from how do we actually mitigate all injection type of attacks, and when an injection attack happens, you need to remember this happens anytime when you are building a string representation of some type of code, and then you are using user input directly into that piece of code. Now, you would most likely would want to use a combination of leveraging libraries that are safe by default, use strong input validation, or you want to escape or encode some of the special characters there. Now, this is if you don't have a very specific remedial action for your technology. For example, SQL injection, we actually would want to instead do parameterized queries, and then all of these extra defenses would come on top of that. So with that said, thank you for joining me for SQL injection and a little bit of a deep dive in there. I did flip around the order a little bit and did the demo before, because now I'd like to jump into some questions directly. I am going to go through some of the things over here. I see there is a bit questions, and then let's hopefully I can answer all of them appropriately. Okay. So some of the question here, just a quick one. Yes, all of the attacks that we've shown today, yes, definitely SQL injection attacks. And on top of that, there was another question. Is the delete or insert functionalities only applicable for SQL databases that you create? So you should be able to manipulate the actual database that is there. Sometimes maybe they can lock it down where they don't actually want you to edit the database at all. What I mean by that is, so let's say you have your application and we have a e-commerce application, right? Where you have your products. Now you can imagine how would they want to add new products onto the application? Maybe there's some type of administrative functionality that allows you to create a new product, and that's then submitted, and that's then created in the backend. So because the application then has that ability to actually, do that type of editing functionality, you would also have that ability to do it. With a database, you can think of it as you have the ability to perform CRUD operations where you can create, read, update, and delete. So something that people tend to default to when they do find SQL injection, they want to, let's say you are wanting to, you are unauthenticated, you're on the login page, you want to get authenticated. So you want to compromise some user accounts. You find SQL injection, and maybe your first intuitive thinking is, okay, let's go and extract all of the usernames and passwords and crack those credentials. That's a good idea. But an easier method might be to simply create your own user. So then you actually create a user for your own user account, and now you have a valid user account where you can log in. You don't actually have to extract all of that information for that specific attacker goal. Similar is, let's say you want to become an administrator. Instead of compromising an existing administrator, why not just make yourself an administrator? So you do have that power. I'm looking at the very last one over there. So if I think I'm understanding your question. The core of it is there are different ways of querying your database. So yes, you can actually use the database function, or you can do something similar to what we did now, querying the actual information schema to do things there. So if you, I think, were to look at Pen Tester Monkey, that's quite a nice resource where you can look at some SQL injection payloads and how they work. You'll notice that there are a bunch of different ways of actually how to do things. Another good resource for SQL injection is Hacktricks, actually. So then you can look at those and see there's different ways of doing things. Yeah, definitely. I believe you should be able to complete your task using Kali Linux. You just need to make sure that you have your VPN connection ready. So this is similar to what I've actually done is I've downloaded my VPN configuration file based on my TryAcme account, and then I have connected to the lab over here because the lab that we went through now is actually hosted on TryAcme. I've kind of put it there for us, and that's similar how I would do it. So yes, I would definitely you can do that. I don't see a problem with that. See, there is a little bit of confusion happening. Please definitely ask some questions. If you are confused, don't worry whether or not it's going to be a stupid question. The best advice I can give you is this is obviously you are hitting, depending on your background, you might be hitting a bunch of new technologies here. For example, and concepts. We are hitting server-side technology now. We are going through to database technology. So it's definitely a little bit of information overload potentially. And my best advice that I can give you is just to get your hands dirty with it. Where my definite kind of example would be to go look at W3 Schools over here and just play around with SQL. Don't do anything yet. Don't try to attack this. This is meant for just exercises. Literally just go to W3 Schools and then say SQL tutorial. And this is showing you from a developer perspective how SQL works. And then that's going to kind of just, allow you to manipulate databases in itself. And that's going to hopefully get you to the point where you can get more comfortable in actually exploiting SQL injection. So the demo that I showed you earlier was actually through Kali. So I am on Kali over here, but just to quickly show you with my configuration file. So, I mean, I do have the configuration file over here. I see it's a little bit small, but I have downloaded my VPN file from TryHackMe. And honestly, I would just advise you to quickly grab a YouTube video on how to use the VPN connection on TryHackMe. When you download it, you would simply use OpenVPN to actually connect to it. We here sudo OpenVPN, type in your password, and then it's going to form a connection to TryHackMe. And that's how I should be able to still connect to Bazaar Bank over here. Then you would do everything as I showed you just now. Yeah, thanks, Ethan. Those resources are extremely good, and that's exactly the resource that we're talking about here. And once again, I know if this is like completely brand new for you, or you feel a little bit more uncomfortable and feeling a little bit more, overwhelmed, just go through some of those exercises. It's going to be very clear very quickly. All of those exercises there is going to show you the exact same steps as to what I went through. And you'll start noticing as you play around with it, what you can actually do from not just the attacker perspective, but you're going to learn how SQL works and what you can do with that. Are you able to send some statements through? Ethan actually sent through that link. Maybe I should also just send you exactly the link that I used. So I would definitely go through that resource Ethan sent in terms of the SQL, because it's going to show you everything. And then if you just want to play around with SQL, not SQL injection, just go to this one. Let me There we go. So this is the one I always use. If I forget for whatever reason how to exploit SQL injection, I would literally go to this and play around with SQL until I'm refreshed. Awesome, guys. Thank you so much for time tonight. Once again, I realize this is quite a lot to take in, but just go and get your hands dirty, and I think things will be a lot more clear. Thank you, everyone. Hope you have an awesome night, and good luck with the exercise. And hopefully I'll definitely see you again for another teaching lesson. Thanks, everyone. Goodbye.